Test. Oh, there we are. Yeah, okay. Testing 1, 2. Well, seems I lost all my subscribers. But then again, why is it not working? It is so weird, so incredibly weird. Why? Why? I don't understand what is happening. Okay, detaching to 0 signal. We did read 1025 bytes. What? That's 1 byte too many. That cannot be it, can it? I think I'm using size of buff somewhere. Let's start fixing that. I see I have finally some viewers, some of my subscribers, or I know I haven't been here for 2 days or something like that. And the reason is that I really wanted to fix my compiler output filtering off stream. But It's a problem in itself. Size of buff is not right. Let's use a lab buff size. Bytes red is 1024. Yes. Now what happens? P pointer plus is, well, I think that buff is what we just read. Starts with script started. P pointer is equal to that. Script started. So now I'm setting p pointer at the end of the buffer. Next, yeah, print. P pointer is empty. End of get area is put to, well, the number of bytes read. So now that's also equal to the, oh, wait a minute. I'm probably doing something stupid. Okay, so far so good. Now I get the end of my message, which should be at the carriage return. No, that's after the, sorry, yeah, that's after the new line that comes after this first line. Script started. Command doesn't print it, but somewhere. Let me think what happens next. If not, that's not the case. If end of message, handle end of message. Well, just printing it. Okay, now the get pointer is set to end of message. That seems correct. And then if the get pointer is unequal buff, and it is, then the size is what we just printed. No. The size of the amount that we have to move. And the shift is the amount that we just got. Printed, I mean. The sum of those is 1024. Pogo, Danton, hello, Eve, hello, and Srini. Try the GDB T minus TUI. Why is that better? I never used it. What does it do? Let's go. I'm moving back. G pointer. Okay, so I already said it, but I have not been streaming for 2 days because I wanted to fix my compiler output filtering off stream. The first day I wasted with battling with AWK, which turned out to have some kind of bug. So now I wrote an application in C that fakes a terminal and then does all the filtering. And it still doesn't work. So I thought, well, let's go online. So now I'm writing a C program that fakes being a terminal and then reads from the output of Ninja and then does the filtering that I want. For some reason it stops printing after the first error. Well, that's what I want, but after the first line of the first error. That's not what I want. Let's see, the G pointer is the get area, and that's going to be the next line that we want to process. As you can see, this line starts with the character return and it ends on escape square bracket K. That's an end of line indicator for me, because here it waits. And then I already want to print it. After the K, it stops printing. That's during compiling. Okay, if I'm moving this, then it would be nice if the GDB would just print the whole buffer, all 1024 characters. It thinks I can't handle that, that's why it doesn't ... But I'm too lazy to look up how to make it print more. Let's just do next. The get pointer equals buff, okay. End of the get pointer is the get pointer plus size, I guess. Yeah. Put pointer is shifted back by shift. And then we're done. Now it reads another 226 because that's the space that I made in the buffer. Yeah, it would really be nice if I have to look it up. How can I let GDB print everything, the whole buffer? GDB print long or wide strings. And the answer is set elements. Set print elements is 0. Print, oops, so print buff, everything that's in my buff now. Plan B, hello. So these are 1024 characters. And I'm expecting a character return, 04, the building, the object, followed by escape square bracket open K. Then we get a character return again and 14 building object until here. Also escape square bracket open K. Then we get 2 character returns and a new line, because now we're going to print something else than progress stuff. And that is escape square bracket open, the red color, that's just ASCII colors is. Failed space, reset the color, escape square bracket open 0M is reset color. And then we get the target, so the object file that fails, followed by 2 character returns and a new line. Why are there 2 character returns? Nobody knows, but it doesn't matter. And then we get the line that is used for executing the command, so the command that fails, I guess, which is longer than fits in the buffer at the moment. Okay, so I'm getting to next. The put pointer is incremented by the number of bytes that you read. That makes it equal to the end of the put pointer. So the end of the put pointer is at the end of the buffer. I put a 0 there so you don't get the rubbish. And put pointer is as the same value now. Yep. And the end of the get area, well, is not byte. No. Is it? Actually, it is. I'm saying no, but yeah, also the end of the get pointer is always equal to the put pointer here. So I'm not even sure why I'm using two variables, except that the get pointer is a character const pointer and the put pointer is a character pointer. So I want to write to it. Two variables with a different type, but the same value. So we do next, and also the end of the get area is pointing to the same value. Now I'm going to find the next end of message starting at the get area and not looking further than the end of the get area. And the end of the it should be finding this escape square bracket open k, and then end of message should be put after that. So end of message should be put at the character return 1, 4, etc. Pretty sure that works. So I'm just going to do next. So now end of message equals indeed character return 1, 4. And then we say if we do not have an end of message, well, we do next. If end of message, handle message. Yeah, shall we walk through this? Okay, let's walk through it. Step. Going to handle this message now. It kind of would be interesting to know, but it's passing a length. Len is 96. Yeah, well, I guess that's the length. P is start, E is, okay, I'm print E, that's much easier to see. That doesn't look good. Did I already execute this line? Frame. Oh, this is, sorry, it's printing here. Wait. No, here. That's nonsense. E should be start plus length. Print P. Oh, it is longer. Oh, right. Yeah, okay. It's confused. I was thinking it was already printing this, but that's totally correct then. Next, if length is larger than 6, yes. Is it ninja? No. Is it failed? No. Does it start with a character return and then a square bracket open and the next is a digit? Yes. P plus 3, and is the next one a digit? Is it still less than E? Is the next one a slash followed by a digit? Is the next, this is C coding for you in a bad way. And when another digit, and you have a closing thing. Print to stand it out. So I just found out that this is what it begins with. And I want to print it to stand it out. If print to stand it out, yes, flush standard error, right to stand it out. And there is our message. Slightly confused. Oh, the 128 is the GDB output. So we are now in line number 128. So I did print all the way up to the .o, and also I think the escape square bracket open k. We don't see that. And then GDB started to print again. if, right? Yeah, well, it succeeded, I suppose. Next. Now the get pointer is set to end of message because we skipped the message that we just printed. If the get pointer is unequal to the beginning of the buffer, and it is, then I just move everything back. Inefficient, but did not want to get too many buffer overflows, I guess. So I have code for this kind of thing in my C++ libraries as well, and then it is extremely optimized. But yeah, I don't know. Would take me half a day to get that working, I guess. So I thought I'll just do a quick hack in C. So we want to move end of G pointer minus the G pointer. Let's say amount that must be moved, and the shift equals this. And then we move from G pointer to buffer, that size. So now buff equals starting at catch return 1 for, and still till the same ending because there is not more. And now we should reset the get area to the starting of the buffer, and the end of the get area is set to that. Okay, and the put pointer is set shifted back, and I still should be the same. So now this one has that value, and this one has the same value. I guess this is junk, right? So it's something of a previous line. Say it kind of confuses me. Oh, this is the old value. This is the old value from here. I shifted everything back, so now the home slash k ends here. And this external stuff is the junk that is left over. So it's indeed junk, but it starts there. Next. So I read another few bytes, namely the amount that we just shifted. Did I not print the shift? So lazy. Bytes red equals 0, nope. Byte red less than, nope. Put pointer plus bytes red. So that's put to the end of the buffer again, I guess. And of the get also. Those two are the same, right? So they are now empty again. And then get the next end of message, which is pretty much the same thing. Okay, I'm confused. How? What? Yeah, of course. Yeah, I'm looking for an escape, but it's gonna take a while. Yeah. Let me see where we are. Pointer. Am I looking for an escape? I'm looking for this escape, yeah. And it's going to take a long time. Print P. Oh. Pointer, are we there yet? No, not even close. Now we're almost there. No. Yes, we are there. And then if the next one is a square bracket open, we found this one, yep. And the next one is a K, then last is escape square bracket open K equals 1. And it should be, end of message should be put on this character return here. Print end of message. Yep. End of message. If end of message, handle that message. Well, I believe it. This is the same thing, isn't it? Okay, this is what I wanted to step through, really. So now we just find that it is not ninja or failed, but it is equal to this thing, and then we print to standard out again, and then we have the 1/4 output. And then the get pointer set to end of message. It's not buff, so we move it back. And now we read a little bit more. I think I know what the problem is. Shall I stop debugging? Shall we continue? I think the problem is that I'm jumping back to the top of select without processing everything. Instead, I should jump to find end of message. Now I can stop debugging. That's the whole problem. Blip, blip. We should not jump back here. We should jump back to find end of message. Let's see, how's this? If we have an end of message, and if we don't, then maybe we still do. Handle it and jump back to the top. Continue. Otherwise, break out. But that's also not working because now I didn't do this part. Let's see, the get, if I handle the message, just moving get pointers pretty much correct. Now I think about it. Well, there is some explanation here. I have this in my buffer. The square bracket here is just the start of my buffer, and this is the end. And I expect that what is in the buffer is a part of the old message, then the next new message, and another new message. and maybe a partial message that isn't complete yet, and then there is some junk still in the buffer. Now my pointers point to gpointer points to the beginning of the new message that I have to decode, and the end of the get area points to the beginning of the junk, so after the what we last read, even if there's not a complete message yet. The put area pointer points to the same place, and the end just points one past the end of the buffer. Now find end of message gets past the area with valid characters, so this part, and what it returns is either a 0 if there is no message. For example, if I pass this message is not complete, so as gpointer it points at the beginning of partial message, then end of message will become null because this message does not end with an end of message sequence. There is no message, no complete message. But if we start here, then end of message is going to return 1 byte past the end of the first message, so it's going to point there. Cloud lol, yeah. Gpointer. Yeah, so end of message returns this position here. Now this part here is, let's skip this part. So if it does, then I handle that message by passing gpointer and the length. So gpointer is this pointer still, and end of message minus gpointer is then the length of the new message. So handle message gets passed, pointed to the beginning with this length. So the first message that we find is being passed to handle message. Then gpointer is set to end of message, so gpointer is moved to point to the new message number 2, and we repeat the process. So that goes on, then it gets new message 2, and then gpointer is moved to there, and then we call end of message, and then it returns null because there is no end here. And then we do this, meaning gpointer is unequal to the beginning of the buffer. The buff is here, didn't add that, but it's here. Can add it. So if gpointer is unequal buff, and it is because it's pointing here now, then the size is end of gpointer minus gpointer, so that's this length, and shift is gpointer minus buff, so that is this distance here. And if both are larger than 0, then move to buff from gpointer size, aka it moves this to there, moves to the beginning of the buffer. Then gpointer is set to buff, so gpointer is set to the beginning. The end of gpointer is set to gpointer, which is buff, plus size, so this length here. The end of this message is now the end of gpointer, but then shifted back here. So yeah, end of gpointer becomes something like here. And the p pointer is also shifted by the same amount. So each end of gpointer and put pointer is just, they continue to point at the same byte. And then we continue to the top, reading new bytes into the buffer. Now this line here was in case the message is so long that there is no end of message at all. the message doesn't fit in the buffer. So if there is no end of message, but the put pointer equals the end of the buffer, so there is nothing we can even read, then I pretend that there is a message, and I set that to the EG pointer, which also should be one past the buffer. So then I'm going to say, well, then just handle the whole buffer as if it is a message. And then G pointer is set to end of message. Now G pointer is set to one character behind the buffer. And then we do continue. So then I'm calling find end of message with twice the same pointer. That better return null. Let's see if that happens. If start equals end, then this is never true. Pointer is not less than end. So we return null immediately. And then we get into an infinite loop. So that would not be good. So I should not jump to the top if p pointer equals n pointer. This is now good. Yeah. This reads a little bit ugly. Let's make it a while loop. But then I don't enter it in the first place. Guess I'm just going to duplicate it. So we cannot find anything but the put area. There is no room in the put area anymore. Then set end of message equal to G pointer and handle the whole buffer. So I do not have to set end of message anymore. I'm just going to handle the whole bloody buffer. I'll G pointer to what G pointer till end of G pointer. Everything that we have. And then after that I just want to set G pointer to the end of G pointer. And then also break. No infinite loop. Yep, now it works. Though I see it looks like it's printing one extra new line here. Yeah, if the input has two fails. Oh no, the new line is here. That's correct. So I'm just putting another failed in here and put the ninja at the end. Ninja build stopped. Do not print this. Let's remove the beginning as well. And this. Now just it prints two failed. Okay, so the whole idea is that it prints only one failed up till the next failed. It's still not working. Oh, wait. Okay, every time I see a failed, I increase errors. And then while error is less than or equal 1, I print this. Otherwise, it's still printed, but it prints suppressed. What I don't get, however, is that I did not see the suppressed. So let's comment this out. In the end, this should not be here, and then I really do not want to see. It's still printing it. Why is it printing twice failed? That's really weird. Weird. Maybe error stays at 0. If this is never working. Yeah, there's a square bracket missing here. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 characters. Now if you find a bug and it still doesn't work, it's the worst type, really. Let's put breakpoint on 56. Run. Print start. Next. Not next. Continue. Print start. Continue. Print start. Okay, this should match. What is len? Len is 89, that's larger than 17, and string n compare start equals escape, square bracket open, 31m, failed, capitals. Why? There's also an n case compare, but I don't think this error changes. Failed. And did anyone say this in the chat? Because I'm going to give you a moderator and ops, and I'll make you administrator. No, nobody said it. Okay, too late. It works. So now it only prints one error. The Discord link expired. Let's make a new one. Get alt tab. Again, let me type something in Discord also. Sorry, I was trying to fix the compiler error filtering of stream. But I think I just got it. And then we make a new invite. Set a new link. Yeah, it's a new link. Fidelity. The goal is to confuse as many people as possible and then take over the world. But unfortunately, BlackRock / World Economic Forum has beaten me to it. So now the only thing that is left is a hobby, I think. Until they shut down my electricity and demand to inject myself with poison in order to get internet access. Let's install this thing. So now it is running again to standard error. So it should be able to use my previous filter again. The filter that I had was begin Yeah, that one. So to limit the amount of operator less than output. And it works. Yippee! Yippee, yippee, yippee. Might as well even test the... yeah. Perfect. It was not possible with AWK. I had to write my own program. Now it's been 2 days since I worked on the Vulkan project, and I forgot completely what I was doing. But I assume that it crashes if I do this. Yes. And then maybe we can pick it up from there. I remember that was the last error. Call log descriptor sets before calling descriptor sets. Yeah, that makes sense. Otherwise, it's not thread safe, right? Cannot just go reading everything without first taking a log. Other threads might be writing to it. Okay, guys, so you think I should add my FAQ to the description? Like, no, that's not an FAQ. The goal of the project. Use the first one who asked that. No, that's not true. Multiple people have asked it. I just don't know the answer. Someone that I do not know said, "Hi, how are you? One mutable server." Ah, this is my the thing server. Okay. Okay. Why is this not going the way I want? Where are we now? Who is calling descriptor sets? No, COBOL is not useful. It's only banks are still using it. Old code that I do not dare to touch. Well, I watched a YouTube about languages today. Someone summing up all the programming languages that exist. See if I can find it back. I watched it on my tablet, so I have to find out the right keywords. I guess programming languages iceberg, maybe. Yeah, that's the one. It wasn't super interesting, but I watched it today, so I thought, well, maybe my viewers are interested in it as well, just to get some kind of overview of all the different languages. So the COBOL is down here in the area of historic languages that are no longer useful. There's a lot of languages. I'm going to find out who is calling this and why they are calling it without first calling log descriptor sets. Or maybe I should just run it in the debugger. So our core dumping thread is thread pool 0. Where did it call this? Not long ago. It is a log, but apparently not logging enough. There's entering. The indentation returned here, which kind of means we left this function again. But that doesn't mean that, yeah, I don't know. I have to get into it again, I'm afraid, because I have been doing compiler filtering stuff and fake T2I and AWK stuff for a few days. I'm going to find who is calling this. I think that's what I'm going to do. Grab project sources for the descriptor sets. That looks like a declaration. I'm using it as a variable name as well. So this is the only place where it is being called, it seems, at the top. Of course, I should have done that. We don't want to get the allocate one. And now we're down to one line. And the declaration. So we're calling it from here. And the reason that I think that log descriptor sets should already have been called is because this is inside the thing that is constructing it. Allocate and update missing descriptor sets. Yeah, first we're filling this missing descriptor set layouts vector. Which is being filled here. But here the descriptor set is being called. So I guess this should do it. This should lock it. I'm completely out of it. Horrible. Yeah, how did this work? Okay, turn my own music off. Okay, well, I'll talk to myself about the refresher that I need, and that then might also be the refreshing of the people that are watching this. I've been coding since I was 12 years old. So multiple threads can be calling this at the same time. And we begin with filling descriptor sets that are descriptor set layouts that are missing. Really? Not really. It's filling this with layout handles of descriptor sets that are missing. So the layouts are not missing, but the descriptor set themselves. And I'm going to create new descriptor sets using the layouts in this vector. And the way we figure out if something is missing is by looking at what we need and then see if it's already there. And that works as follows. We run over all the set indexes that we need, which is kind of a ID, say, to hook up shader resources that we want to be in the same descriptor set, and already put them in a basket, so we can run over the set index here, and then we can run over shader resources per set index with the set index as an index, and then we'll get all the shader resources that should be put in the same set index. We also know the binding that they should be using. We also know what the layout should be. This points to that layout. As you can see, there's certain things that it should never fail, so we just get it here. And then we do something smart. We take a lock on some information that is stored in each shader resource, so that there is no race condition between two different threads in adding this stuff. Because if we decide that the descriptor set that we need does not already exist, the thread is going to create it. But since multiple threads could be running the same code here, multiple threads could come to the conclusion that they need to create it, and only one is allowed to. So that's being stopped at this point here. The first thread that takes this lock blocks all the other threads. Okay, Okay, it doesn't really block it. It does not really block, but if the log fails, it returns in progress, and then we return false, which means that this task, this part of a task, pipeline factory task, is no longer being run then. So the task halts, not the thread. If we do get this log, then we take then we log a real mutex, read mutex, for read access, read write mutex, but we read log it, and you got to wonder why I even do that, because I don't think any other thread can get here. Or maybe it depends on a few other things as well. Yeah, for example, if the binding number is different, so one thread wants binding 0 and another thread wants binding 1, and then they want a different descriptor set. So then still both could pass here. I think. Anyway, it's safer, I guess, to just have this protected by a mutex as well. I think it's per set layout bindings is. It's a map, takes this as a key. So it doesn't really matter if the key is different for two different things. We still need to make sure that nobody is write logging it. But this is a read log, so yeah, multiple threads could pass here and then they can both get a read log. It does stop, however, writing to the map, because, well, we are reading a map. You don't want to write to extend the map while someone's reading it. So, but multiple threads could be reading this, that's no problem. And then we run over it. That's exactly what we do here. We read it. And then we get okay, let's refresh my memory on what's in it. Where's my C right here? And this gets a read access type from that thing, which happens to be a AI thread safe wrapper around a standard layout bindings to handle container type, which is a map of with the key set layout binding and set handles as the info of the map, and that set handles is a wrapper around a vector of descriptor sets. So if every shader resource involved has the same descriptor set stored in their vector, any, and then we already have that. So this value type is a pair of the key and that set handles thing. So if we look at the first, then we get the key, which gives us also the binding number that is part of the key. If that is equal to the binding number that we require, then we can consider it as, well, then it contains possible the VK descriptor set handles that are compatible. So in that case, continue here, and then the set handles is the from of that pair the second part. So that's the set. We get the set handle, the set handles object, which is a wrapper around that standard VK descriptor set. I mean vector. So this is the vector, and then well, we can get that as well. And it asserts at this point, because it says you have to first lock it. Right, well, descriptor sets. Now if I could get access to this list here, then we can run over all the descriptor sets that are bound to this shader resource that we're handling right now, and then I increment a counter for that descriptor set, and if that is equal to the number of shader resources, then that means that all the shader resources support this descriptor set. And if that keeps being the case until we run over all the shader resources that we need, then we still have a match. So then we don't do this. Hey Breton, hi, how are you? How are you? Okay. Still have matches true, yeah, etc. Okay. It seems to me that what we really wanted here is a read log. A read log on the descriptor sets. But it's a normal log. It's not a read-write log. It's just a yes-no log. Only a write log. A log for reading and writing. And I'm not taking any log at all at the moment. If I do that, I mean, we are only using it from here till we don't use it anymore. We only use it in this loop. So I would say to here. I could take the log that is required. No, I did not change anything. I worked on the filtering. So I tried it with AWK to get the filtering working again for the Ninja output. And that failed, and then I wrote a C program that does it, instead of doing it with bash scripts. No AWK. My program also splits it up. So my program that I wrote fakes a T2Y and then filters Ninja specific progress messages and writes it to standard out. And error messages are written to standard error, and they are filtered so I can only see one error, only the first one. So that's the bulk part that is required for filtering, and then I'm still using AWK in my bash script to filter the standard error for a long output, like missing an O stream Operator less than less than. I had another thing in there. No, I think that's the most important one. So okay. So what it requires here is a call to log descriptor sets. What is that doing? It is a call to mutex. That's a task mutex. Aha. Yeah, Noxy, I just learned it by myself. Coding, I start coding. I mean, I learned it decades and decades ago, so it was just books, no internet. I took a manual and I read it and I started typing and I learned myself programming. Yeah, it's just students. Yeah. Good plan. That I won't be crying, I'm afraid. Maybe I will. But not because C++ is difficult. More my project is difficult. And the very idea that changing languages would make that any different is laughable. Laughable. Maybe I will laugh. Right, so what this does is it calls a log. If it succeeds, it returns true. If it fails, it does not block, it just returns false. And you would say, well, then it's a try log, but no, it's not. Because the idea is that when this returns false, I have to return to the task engine saying that I'm waiting. So the task stops running, but the thread doesn't. That's why this returns. And then when the task that did get the mutex unlocks the mutex, then all the tasks that called log and returned false are started again. So we will enter at the point in the task where it stopped running. And currently I have only one place, so say this function or that we are in now. I mean, if I would look at this error here and it would fail and I would just leave this function with a return false, then this task would stop running and it would at best enter at the top again. Completely at the top of this function. And try everything again. And I'm not sure if I'm super happy with that idea. It would work, but yeah, difficult. See, I'm doing the same here. If at this point the shader resource is basically already being considered, I'm returning false, and we're just going to restart later from the top of this function. And the reason that I need to restart is because the thread that has this logged might add the descriptor set that I need. And this is inside the loop over all the shader resources. So I might already have discarded something, looked at the previous shader resource, and thought that it did not have a certain descriptor set. Therefore, I have to start over. And I guess that the same holds for the same holds for this point, except that it wouldn't be the case if the task that logs this fails anyway. So maybe it's better to use normal mutexes and really have them block completely until I know if a certain thing is succeeding. In particularly when I'm adding it. So a lot later I should be calling this function again, I think. I hope. No, I'm not. There's missing something. I think it would be this one, update descriptor set. Nope. No, of course not. So this one, add set layout binding. No, also not. Yeah, feeling really desperate here about the fact that I did did something else a few days, and that has erased my memory. I mean, if you were here then, I talked about the feeling about what is his name? The Doctor of Star Trek, I think. Doing a brain transplant on Spock. Yeah, that's basically how it felt. And then I stopped in the middle. Did something else for a few days, and now I don't know anymore how it works, man. I don't know. What the hell? What is this doing here? Oh, that's just a creation. Okay. Yes, so I should be skipping this if the shader resource is created, but not really. That's the whole created and updated descriptor sets. Oh boy, it is it's still difficult. Creation of the shader resource and binding is different. It should be split, I think, into two parts. So I have a single boolean now, and I'm creating the shader resource, and then I'm trying to find the descriptor set descriptor set handle for it, possibly creating that, and then bind the shader resource to it. And if that fails, we re-enter. And all that time, I'm not setting this boolean, because I did not update the descriptor set yet. But it was already created. That doesn't make sense. Why am I doing it like this? I feel like deleting everything and starting over. Except I still don't know how to do it at all. Yeah, just student, it's not C++ that is confusing you. No, Thijs, thank you, but no, it's not even Vulkan. It's just my project. What I'm doing here right now is not understandable. But it definitely does not have to do with C++. It doesn't matter what language you use, except that certain languages you would not be able to do it at all, and you can in C++. But it's okay. So at some point I am calling, say, add uniform buffer, meaning that I want that uniform buffer to exist, which tells the current pipeline factory to create it if it does not already exist. And for each pipeline it creates, it must bind the shader resource. But that's a totally different thing. It is a totally different thing. I'm going to rip this updated descriptor set part from this boolean. Sorry, refresh my mind. What does DSA slash CC mean? Okay, just student, you are now officially labeled a troll. Which is sickening, immature, pathetic. No time for it. I'm not even going to wait until you show that you're not a troll. I don't like trolls. Can go have his fun somewhere else. Well, at Hirai, why are all those names so difficult to pronounce? Usually I avoid STL as being slow. I don't like slow. But this particular code is more or less executed only once. So, and it is so complex that if I would try to avoid the STL to win a few clock cycles, then I would not be able to write it at all. I just need STL because of its complexity. Oh yeah, this is full of it. I use everything. This part is totally full of it. Maps and sets and vectors and DQs and everything. Okay, let's change this boolean into just created. Hey Demira, you're back. What do you mean they look like plus 23? They look 23 years older than you, or they look like 23 years old? So I can I can make this change because this is inside a loop where we are exclusively creating it. Storing to m acquired required shader resource list, and which is then being created here. So we get past this point, then the booleans should be set. It might be used immediately, even during this call. Well, that's still true, I think. Although it gets a lot less likely, because it still has to be bound. Demir, well, that's an advantage. You cannot look cuddly enough. Everybody will love you. Trust me, you'll be old and ugly in no time. So do your benefit with it. And Adhira, this is what I do all day, every day. And I'm very experienced, yes. Been coding 46 years, 28 years C++. set created. So let's move this to where I just created it. Because this is where I just did the update. And want to rip it from there. Allocate. Okay. And create. This is initialize stuff. That is where we're doing it. And I think I cannot do it here because it might be used immediately. I can do it here. Just immediately after call to create. Thus, I hate this. Thus, at the moment, set created is being called. It just sets a boolean. Yeah, well, okay. So it doesn't really have much influence except that is created might return true. Now we call that a little bit higher. So the result would be that a thread that wants to create, say, only this one shader resource gets here and suddenly does a continue without trying to acquire a lock or anything. Which might cause it to pass without adding it to this vector here, therefore not running over it here, therefore skipping this and not calling create or set created again and returning true. And then we return to wherever this is being called from. So this returns true, which means that we're not waiting and we're falling through to calling initialize shader resources per set index. And then we just get this race for creating the allocating and updating the descriptor sets. So that's fine by me. I think that Boolean change was correct. Why the hell did I add a fix me without adding text? It's the same as up here. Why is this suddenly working? I don't know about Google, but they don't function all the time. Oh, that's good that I see this. I think I have something that I need to put outside. Yeah, I should do that, I guess. It takes me more than 5 minutes. Do they stop the stream? I'll be right back. I'll give you music. Okay, Why is the music so loud? Oh, because I'm listening to it like that. And you guys are not listening to it at all. I gave you music, but I didn't. I gave myself music. And I gave myself that. So if this function here returns false, then we definitely need to wait. Definitely. This is my wait thing. You're not going to tell me that I'm already doing that somewhere. It's impossible. It's not even allowed. Okay. Therefore, if that allocate and update missing descriptor sets function is returning false, then we leave this function here, and that means that the task is waiting, halting, whatever, until it starts running again. And that happens when another task unlocks a certain mutex. That's this one. So we're trying to lock layout binding, so set layout binding. And this is passing that allocate and update missing descriptor sets flag bit with the value 8. It's called condition. And that condition is passed to lock descriptor sets. And well, passed to the mutex lock of the current class, which is a set handles. Oh, it's actually surprising me. I thought it was protecting something else. Well, this mutex here is being locked, and that is the mutex that is protecting descriptor set handles. This one, which was asserting. When I called this function here. So apparently I already added the code. So this log descriptor sets is being called here at the moment that we call log set layout binding, which is being called from here. And still I'm asserting in this call, saying that it wasn't called. Okay, yeah, D. I only now see it. You can hear the music now, right? I made a mistake indeed, but yeah, because it was from before I went putting out the garbage. Yeah, I was already talking to you. Good, good, good. Is it too loud or not loud enough, or what's your opinion about the volume? Okay, thanks. Yeah, it's a bit hard to say, Mushroom. It is. I have code that I wrote for this project. So, the Vulkan project, I've been working on it a bit more than 2 years now, I think. But the project itself is also using code that I would just call utilities, or the stuff that I would use for any C++ program. But this is more or less the first time I'm really using that code. It took me 10 years to write that. So if you count that in, it's a lot more. Yeah, what the hell, man? I'm confused. Yeah, okay, let's go here again. Allocate up to the descriptor sets. First for loop runs over all set indexes. Second for loop runs over all, yeah, I'll say it again, braces in the first column are debug braces, so you have to ignore them. Pretend they don't exist. So the second for loop is running over all the shader resources of the current set index. The third for loop runs over all the descriptor set handles that are already being used for this shader resource, given the layout and the binding number that we need. That's not true. Given the layout that we need. And if the binding number then also matches, then we continue here. Mushroom, yes it is. And then here I'm trying to get the descriptor sets that are being bound already to this shader resource. And that is not allowed because it says I'm not having a lock on it. But that lock appears to be set in this line. Because here on shader resource I am calling lock set layout binding. Okay. I am passing the condition allocate and update missing descriptor sets. Then it is calling lock descriptor sets. And that is a call on, that is a method, I mean, of set handles. If that lock succeeds, then it returns true, but it also sets mdebug have lock to the current task. Because that is task which was passed as a second argument to this thing, which is pipeline factory, which is the current task. So returning true means that in progress is false, means that we do not return but we continue. So if we get here, then that lock was set. And then I'm calling descriptor sets with the same pipeline factory task pointer, and that does assert mhave lock equals task, which we set here. And that fails. Why? Seems to be only one answer possible, and that is that this set handles is not the same set handles that we used up there. Now the set handles that we're using here is set layout binding handles per dot second. Set layout bindings to handles. You read? So the set handles here is the second element of the pair that we get here, which is the value type of this container. So it is that descriptor set handles object stored in that map. Which you can only access by taking the read lock on it. There's no way we could access it here. Impossible. So then what set handles is this function using? We are calling log set layout binding with a layout and a binding and a task and a signal. Oh, it does take a write log. Takes a write log on set layout binding to handles. And then tries to add it. Okay, so confusing. Yeah, no, I cannot see it. So let's add some debug output. See if the debug output is shining more light on this. I think I'm calling it, and apparently I'm calling it, but on something else. So what if I just print here? Call it an entering. And this is let's add a class to let's add a class to it. Set handles. Log descriptor sets task comma condition. And the accessor, and I want to know when we unlock it again, because that unsets it. Texodar, I cannot remember. It's been so long ago that I learned VI that the only thing I know is that I didn't learn all of it, so I'm kind of stuck with a subset of things that I use. But yeah, those things that I use are just going totally automatic, and so long ago that I learned that those things that I don't have to think. I cannot remember anymore if it was difficult. Okay, so we code up here. That is when we enter this set handle set descriptor sets, where this is task and that is this pointer. A second ago we called that one. That did not fire, so apparently we do have the lock on that. Obviously still the same task, but a different set handles. Here's a lock being called with the correct or the same task, and 108BO or 0. Which succeeded, but this one doesn't. Well, I would almost say that seems to make sense, because this is a loop. We are inside a loop and we're calling simply this multiple times on different set handles. While before the loop we're only calling in the lock once. So entering this function results in a single call to lock the descriptor sets, which turns out to be the first one called in the loop. Okay. Yeah, I could specifically look for that function or that object, I mean. Being unlocked here. But that's by a different task or what? That's a task 1FFD0. I think that's a different task, right? Yeah. McDev, hello. Did that already. Okay, then let's go back to the source code. Not that. This function is being called, and I'm calling some log function. It's only calling the log on what it is inserting here. And or what already existed. It's C++ itself is not that hard. I think in most cases it is people are being scared, or maybe I should say they lack self-confidence. Self-confidence is very important. If you think, oh, I can never learn that, yeah, okay, then you won't even try, so you will never learn it. And if you think, I can learn that, I'm going to learn it, then it turns out not to be that difficult. And then eventually you will have learned it. No, the real problem is when it is a lot. Say, if you want to become a mathematician, you have to read very difficult books, thick books, a lot of them. And just reading those books and doing enough exercises so you will be able to understand all that difficult stuff, that alone takes 4 years. And then you cannot even do it alone. You still need someone who is continuously explaining things to you and correcting you. And so yeah, you can tell yourself, well, no problem, I can learn mathematics, but do you have those 4 years, you know, full time? And then it becomes a problem. But if we talk about C++ syntax, just the syntax, yeah, several months, maybe half a year, going through everything. But 1 month in, you should already be coding stuff. Not using everything, but yeah, take Vulkan. I'm 2 years in with Falcon. I didn't know anything. I still don't know much about Falcon, but I sure know a lot more than when I started. Competitive programming. Yeah, I don't think much of it. I think the way people code when they do competitive programming is not a right way to code. So if you do that a lot, you become a very good competitive programmer, but not necessarily a good programmer. Let's say your code would be quickly written, it will be compact, it will work, but it will not be maintainable or robust or flexible. I always want to cuddle Harvey. Or did you not mean? Did you not mean me? I'm pretty sure that cuddling is somewhere totally up there in the top short of best things in life, and I'm not getting enough of it. Set layout binding. Why are we adding a single thing here, or what? I'm completely lost it again. So you guys distract me. This was the function I mean. This adds log to first, second, where first is the iterator to this thing. Set this key, set layout binding key. Set layout binding key is being used for okay, so this is a map which uses set layout binding as a key. That is the thing that contains that map, and then for the given key I lock this set handles from this function here. Lock set layout binding. So I'm locking the set handles that belongs to this key, which is only a single key. And then we get here. Then I'm getting the read lock access type of this thing here, which happens to be that thing, yeah, that map. And I'm going to run over the whole map. Oh, so I'm getting every key. Not just this key, but every key. Okay, is it, and that doesn't seem right. Why am I running over all of them? Why am I running over all of them then? I should be running over handles. But that's this line here. This is running over the handles. Why am I running over all of these set layout bindings? Really? Set layout canonical pointer. Corresponding set layout. Okay, now I'm convinced that I'm just too stupid, too old. I'm very certain that I would not have had a problem a few decades ago with this. And the problem is purely memory. I cannot have this whole program in my mind. D, yeah. Okay, I'm going to yeah, I'm going to stop looking at chat, so I'm not distracted, and then I'm going to try to reiterate or reconstruct what is happening using this ASCII art here. Which I used before to get some insight. There was more here, but I moved it down, I think. And then I changed it. Great. Okay, this is per set index. So for a given set index. And I think that should work. And simplifies the ASCII art. So maybe you can translate what is up here to this, if I didn't already. So for a given set index 42, we have the following shader resources, 8 of them, 4 textures and 4 uniform buffers. They all use the same set index hint, meaning they all want to be in the same descriptor set index. Sorry. They all want to be in the same descriptor set because they use the same set index hint. So what I need is a descriptor set like that, a handle, a vulkan object, that can contain 4 textures and 4 uniform buffers, and that demands a certain layout. I'm not convinced anymore this is correct, because I think this is the layout. Sorry, that's the layout of a single descriptor. Yeah, so the descriptor set exists of this is so what I just said is not true. This is still the set indexes. We have 4 set indexes here. Well, I have to take an example. So in the pipeline layout could have the need for 4 different sets, and each set then contains 2 shader resources. And at this point I know which shader resource goes into which set. Sort of. So this loop loops over 0 and then 1 and then 2 and then 3. And then this loop, when the set index is 0, for pipeline 0, set the shader resource first to U2 and then to U1. And in another thread, at the same time possibly, it loops over U4 and then U3. And then for the next set index number 1, the first thread loops shader resource over T2 and then T1, while the other thread loops over U2 and then U1, and so on. And the binding that we get is the binding that, that is known also for the given pipeline. And then in the first column here is binding number 0, in the second column binding number 1. So for example, at the moment we are at set index number 2 in pipeline 0, and we are in this loop at the second element at U4. Then binding is going to be 1 because U4 is in this column, while the other thread at set index number 0, while being at U4, is binding number 0, because here U4 is in the first column. We also get a descriptor set layout in the form of a pointer. We can have a canonical pointer because every layout is only created a single time in a cache. And the only layouts that exist here are, well, UU, TT, and I guess UT, which isn't used in this constructor. And therefore in this case we get one of 2 pointers, either a UU or a TT, and then the pointer thereof. And below here I wrote about it as well. Shut up. Well, here we wrote about that there is only 2 pointers, either a canonical pointer 0 or canonical pointer 1. That's what is being returned here. Well, not a pointer yet, but an iterator to something, and then we can convert that to a pointer to dereference it and then take the pointer of that. So maybe I should add here, say CP0 was a pointer to layout u, u, and CP1 is a pointer to t, t, and CP2 would be pointer to layout ut, but we don't use that in this example. That covered all this code, right? Every line. Right, this deviates, I think, from the above example, because we have here 4 resources, and I'm pretty sure that that means in a given index. Now, while above, for each index, I only had 2 resources. Plus, code was changed after I wrote this comment, so it might not be accurate anymore. We read it. Assume a given set index requires 4 shader resources. Yeah, so that's not the same as here. Here we have just 2. And now we make that 4. And because I do not know if it's a texture or uniform buffer, there are many more shader resources, by the way, but they are more esoteric. Esoteric, what is it? What's the word? So I'm not considering other shader resources currently than just texture or uniform buffers. Anyway, I'm calling it an R here, and then we have well, X as the index. I believe that later I put them in the order of binding number. You see here binding 0, 1, 2, and then that's automatically R1, R2, R3 and R4 are per definition in the order of the binding. So unless I see an R5 somewhere, which I don't, I really think we should rename this. It's just silly to start at 1 when they are ordered as binding numbers. That doesn't really mean they are binding numbers, but there are just enumerations of shader resources. So I could use 1, 2, 3, 4. I could even use 10, 11, 12, and 13, or whatever I wanted. But by picking 0, 1, 2, and 3, it's make it myself a little bit easier, because I then immediately see what the binding number is that we want. Maybe it's not true. This is the order in which they are being processed. Ouch. Yeah. The order in which they are processed are not equal to the binding numbers, per se. Not at all, even. Or are they? No, not sure anymore. Let's undo this. I'm gonna undo this. Not sure that it is even true that the binding numbers in that order. What it says here, and that is most important, is that this is the order in which they are being processed. Meaning that for a given index, for a given set index, this loops in the order R1, and then R2, and then R3, and then R4. And the binding is more or less random. Just we get the binding, whatever the binding is. So it's not true that the binding numbers are in the same order. But the reason that each thread is processing them in the same order is because this vector was sorted. And it is a vector of pointers, more or less canonical pointers. These are objects to a specific shader resource, element of the window glass that the user made. Different pointers should mean different object. Different shader resource. As in, it could be a texture, and I have two texture objects, then I will have two different pointers. Two different objects means two different pointers. It's never going to happen that I add a texture to the engine and then I make a copy of it, changing the pointer, and then I add that as well. That would be nonsensical. But it would still mean that the second one is a different texture. So since shader resource per set is sorted by canonical pointer, all pipeline factories will process the shader resources in the same order. let's say R1, R2, R3, and finally R4. So those 1, 2, 3, 4 are really pointer values, which are absolutely nothing to do with binding numbers. Binding numbers, by the way, is the order in which they are in the set. So if I show this, put them like this in one set, then U2 has a binding number of 0 and U1 has a binding number of 1. So in this case we are going to have a set with 4 of them, but it might as well be R3, R1, R2, R4. Just some random order, because this order here determines the binding number. The function shader resource log set layout bindings attempts to add a set layout binding with the canonical set layout pointer and a binding that correspond to a required descriptor set. So for a given shader resource, let's say R2, R2 wants to be in, wants to use binding number 2, and it wants to use a certain layout. For example, if this is a uniform buffer, it wants to be in texture, texture, uniform buffer, uniform buffer. And then each shader resource has a map that uses this layout and the binding number as a key, in which that shader resource is being used. So this particular thing could use the layout, like I just mentioned, TTUU, with a binding of 2, which could point to set handles. But why would we have multiple set handles? Set handles, I mean, is in itself also a vector. Yeah, I'm not really understanding it anymore. Okay, so the function lock set layout binding attempts to add a set layout binding with the canonical set layout pointer, say CP1 or 0, you know, canonical pointer, which in this case points to something with 4 types. Pointer end binding that correspond to the required descriptor set. Yeah, and this comment is wrong because I removed it null handle concept. I replaced, at some point I replaced the having a handle or not, because we need multiple handles. So this text talks about, you know, the key exists with a descriptor set handle. So there was just one handle here. There was either a VK null handle linked to a key, or there was some set handle linked to it. Some set handle. But now I change that to a set handles, which is multiple handles. Handle 1, handle 2, and so on. And then you cannot even talk about the null handle anymore, because what we want is either we're going to use the handle 1 or 2, or we're going to add a handle, a new handle. And the intent to add a new handle or use an existing handle is done by locking it. So add an L here, and then I locked it. We are locking the set handles that belongs to this key. So a locked set handles with 0 or more keys then is equivalent to the null handle in this text. Maybe you can already update the comment. Function shader lookup that attempts to add a set layout binding with the canonical. That's not even necessary anymore. Why would I do that? I just want to lock it. Yeah, if it did not exist, then definitely we will need to create a descriptor set. So it can immediately be marked as in need of creation, and then we can continue with the next set index. But if it exists and the handle is not locked, then it might be one that can be reused. See, so continue with next shader resource until it finds. See, continue with next shader resource. Until we find, yeah, we're talking about the pipeline factory. I'm still going to use we, I think. Until we find the case 1, in which case we again mark the descriptor set as in need of creation. And 3, the key exists with the set handles that is locked. This means that someone is already working on this, and really, yeah, we do have to back off then. That was the whole horse race algorithm that I figured out a week ago. So back off until well, the lock is released. Possible states. no key, case 1. So in case 1 we add a key with a locked set handle. And that is different. State 1 and state 1 and 2 are different. So I'll probably need not a boolean but something that returns 3 different states. Continue with next shader resource until we find case 1. Okay, back off until the log is released. At which point we should continue as in 2. Yeah, but the continuing is not that easy. But if I just start all over from scratch, from the top, then we will automatically do 2 because now the key exists. I mean, if it's the lock is released, then the key still exists, but now it's not locked anymore. If it's locked again, then yeah, someone else is maybe creating, etc. This is not stable, but it could happen that the task is going to sleep and then be woken up and gets here again, and then it goes to sleep again and wakes up again. And if there is a lot of tasks at the same time doing this, then it's possible that it would escalate in wasting a lot of CPU, which is what I not really like about this. I'm using a lot of races here instead of just queuing things. Would be better if only a single task was woken up. Maybe that is the case. Now I think about it, that is the case. There is only one. If multiple tasks are waiting on the same mutex, only one is woken up. So chances are that indeed we will continue with 2. Because all the other tasks that would want this and they had a chance to also lock that same mutex or try to lock the same mutex, they will continue to wait until this thread, I think. No, or not, because we don't have the log yet. We don't get it. I don't think we get it. I'm not sure anymore how the mutex, the task mutex works. But okay. There's not much distinction, if you ask me, between case 1 and 2. Because I don't really care if there's a key in it or not yet, except at the moment that it returns it. Suppose I do not make a distinction between it and just return an empty set handles. So we would return here and we did get a lock, but it was empty. Then let's say we're not looping here at all, because it is empty. Then still have matches false. Do I have matches false? Break. Then it is marked as in need of creation, and we continue with the next set index. That's exactly what I want. So I might as well return an empty list. It's not really a difference there. See if I can change this. If the key already exists and the corresponding set handles is locked, it returns false. If it didn't exist, it was created. If the corresponding set handle isn't locked, it wasn't locked. It was locked and returned true. Except that this is changed into a might. That's the reason why I'm not happy, because it's a bit, yeah, it's blocking tasks while it might not be needed and stuff like that, or waking them up, or restarting them while that might not be needed. Yeah. It is still very complicated because no key case 1. I have everything empty now. But now I have the problem that we are locking a vector, multiple possible handles. I think also that didn't do this correctly, did I? Didn't. We first lock them all. So I'm locking here R1, and then if that is in progress, we return false. But if it is not in progress, I'm going to do stuff and possibly continuing with the next shader resource. And then we call lock on that as well. So the picture really looks like first we have this, and then we lock the first one, and then we lock the second one. And then we lock the next one. and then we log the last one. And then we start backwards with unlocking, but okay, doesn't fit on this one line. Yeah. I have the feeling that it's not necessary to lock. Should not be necessary to lock this. Because at the moment we are at R2, it is impossible that any other thread is trying to do the same thing that will be in our way. Because if it is in our way, if another thread is trying to create the same descriptor set, it would be also R1, R2, R3 and R4 with the same bindings. And that thread would also start with R1, with the binding of R1. So if we already lock R1 with its binding, we immediately rule out all threads that are trying to construct or allocate the same descriptor set. Also different descriptor sets, but definitely also, yeah, definitely the one that we are. The one that we are trying to create is a subset of what we locked out here. So there's no reason to lock R2, which would again potentially lock out the creation of a lot of other things, which is kind of ridiculous. Well, a waste anyway. So I think that we should only do this for R1. Call this lock here. Yeah. Likewise, when succeeding in getting everything and allocating the descriptor set and then going backwards, unlock only has to be called on R1. I think that is already the case. Like literally with a construct like this. Apparently not. What? That's the create stuff. Release lock should not even be called here. Yeah, it's because I separated it. Yeah. Yeah. I should move that over here. Highly dubious. Highly dubious. Anyway, yeah, so if I get past this return here, there is no other return, then I have this first log and I should unlock it again. So I must do the opposite of lock. Set layout binding on the first shader resource. Doesn't even exist. There is the unlock, damn it. It's kind of far-fetched, isn't it? Saying that if I call unlock descriptor sets, then I must have it locked as a task. Therefore, I'm the only task calling this unlock. And task is sort of single-threaded. Therefore, I'm the only thread that is calling this. And therefore, there is no need to have it write log. Plus, it's thread safe. Calling unlock on this is command. It's just, I'm gonna add here the thread safe trick. apparently didn't have that thought before. Because by extension then I have to make this unlock. Well, that is indeed exactly the same argument. But yeah, MQ pop, I mean MQ is a Q and then pop is not const. I mean, come on, yeah, well, maybe I shouldn't do this. Okay, I'm not gonna do it. So let's make this non-const. Can either way, got to make it compile somehow. So I'll just take the right log. No, yeah. I don't think I changed anything, right? It's just crashing on the same thing still. Yep. It is still crushing. I even made it worse. Now I'm only calling the log set layout on the first shader resource, let alone on everything. However, there is something that is bothering me. Why am I looping over everything here? This doesn't make much sense. pretty sure that I just made a mistake here. What I want is this. Of a given key. I have to look that up again. What the hell is this type? This returns a C-red. Add that points to something that we find in, which then gives me an iterator 2 what? That's an iterator to a value pair of this. I'll just use this and then the value pair. Well, or not. Set as second. I think I need this. Now I'm running all this already. Why? Okay. Let's use the names that I used below there. So I'm having this already as an iterator. Okay. I have no idea what I'm doing is good, but feels good. Except that I'm now still calling descriptor sets on shader resources that I didn't call lock on. I don't know if that is a problem in the current test program. Apparently not. Okay, it works. Well, ain't that amazing? But it's not correct. So, but I'm going to bed. It's late and stuff. Thank you for keeping me company, people. Always nice to have a working application at the moment I go to bed. Gives you hope, right? Going in the right direction. What, did you disagree, hey Reddit? It was probably a troll, but people are entitled to their own opinion, so I wouldn't care less what people say. Someone comes here and he say, I think every human on planet Earth should die. If I had an atom bomb and I could blow all of humanity up, I would do it. Then removing them from the channel wouldn't make any difference. It's just their opinion and they're not doing it. And if you remove them from the channel, then at most you increase the chance that he'll actually do it, right? It's just weird people. Things that I really don't like is repeating, you know, flooding, so people cannot use the chat. As well as trolling, I guess. It's kind of a sort of a flooding, but then trying to trick people into emotional responses. That then is the flooding. Still comes down to flooding. It's like, what was this exploit? There used to be an exploit where you could send a ping to servers and they would reply with a pong. But they would not reply to the one that sent the ping, but they would reply to the address that you claim that you have when sending the ping. Plus, it was possible to make that a whole flood. Somehow. Now you're entitled to your opinion as well. So if you want to remove it, then of course go ahead. I just saw it and I didn't because I thought, well, you know, losers exist. At most I would say as a personal advice that you could take into account that it really doesn't matter that there are people that are saying really nonsensical things. it doesn't bother me, and if it bothers someone else, then it's their problem. It doesn't make it true when you don't delete it. Anyway, I was going to bed, and I'll see you tomorrow. There's one question I'm looking at here. Coin says, hey, kind of a new question, but I'm new to C++, using it with Vex Robotics. And I was wondering what's a good way to make a loop run, say, for 15 seconds and then stop. Oh. Don't know if Coin is still here. I wouldn't loop. No. If you really want to use 100% CPU, then well, I wrote something that does a delay loop, but it's more for microseconds. Anything longer than 100 microseconds is stupid. You should just do a system call and then have the thread sleep. So that's a tenth of a millisecond. So if you want to sleep for 1 millisecond, I would already call some kind of sleep. I have no idea what that is. But really, I should go to bed, so I'm not playing that now. Yeah, that really looks like my type of music. Genre hip-hop. Normally I really do not like hip-hop. No, I can't play it because if it's copyrighted, then they close my account. The music that you hear is royalty free. Cannot just run random things. No, I don't want to colorize. What a strange remark. Nobody knows how to call this guy. A rare K-pop manifesto. Seriously? Oh wait. Yeah, it's rare. It should be rare. Yeah, the common. Yeah, it's rare. Nothing. Oh, it is this guy. So you can just write a comment, and then you will see it anyway. Well, you go. You joined at the wrong time because I just was ending my stream, really. Yeah, I'm going to end.